Dear students, hope everyone is doing good. In this video, you are going to see class 12th mathematics, which is from continuity and differentiability topic, chapter 5, continuity and differentiability. Which is I am going to discuss continuity and differentiability. The very first thing is you should know what is continuity. That means when can we say a function is continuous at a point in a interval. So first I have to discuss, I am discussing continuity of a function at a point. Before this continuity of a function at a point, I just give a brief introduction about a continuous function. When I can say continuous function from different graphs, I can explain when a function is said to be continuous. See, let me take a graph here. See, for example, if I take like it is x-axis, y-axis. If you see the graph of a function is like this, and where this point is a and this point is b, I take. So when I am just drawing the graph of the function from here to here, I am not lifting my pencil or pen anywhere. I am not lifting. That means continuously I am dragging it, right? Continuously I am drawing. Such kind of, that time I can say this function is continuous from a to b. That means in the closed interval ab, this function is continuous. Geometrically, if you see the diagram, you can easily understand whether the function is continuous or not continuous at a particular point or in a particular interval. One more graph I am drawing. Look here. See, the greatest integer function, if you see, it is like this. Have you remember 0, 1, 2, at 2 it is like this, 3, 1, 2, like this it will be there. So if you see from 0 to 1, I don't need to lift my pencil. From 1 to 2, yeah, I have to lift it here. That means this function is not continuous in the particular intervals, whatever you say. So at 1, what happened? At 1, before 1 it is 1 value it is having, at 1 onwards it is changing it value, at 1 onwards it is changing value. That means when I am drawing the graph of this greatest integer function, it is not allowed to draw me in continuously. It is having a jumping every time. So this is not continuous throughout this domain. So greatest integer function means what? F of x is equal to greatest integer function means it is like this. Hope you remember. So for example, if at all integral points, this function is not continuous. Otherwise it is from 0 to 1. If I take from 0 to 1, you see 0 to 1, closed 0 to open 1, wherever you take in this interval, the value is same. There I am not lifting. In 0 to 1, the function is continuous, and from 1 to 2, this interval also the function is continuous. From 1 closed 1 to open to the continuous. But if I take from 0 to 2, it is not continuous. Why? At 1, what happened? At 1, I have to lift my pencil and draw. I have to lift my pen and draw the graph. So when I am lifting, you have to accept that you are breaking the continuity. When you are breaking the continuity, the function is not continuous. This is the clear idea. One more example I will give you. See, f of x is equal to x square minus 4 by x minus 2 when x not equal to 2, and it is 0 when x is equal to 2. 0 when x is equal to 2. This can be modified as x square minus 4 can be written as x minus 2 into x plus 2, x minus 2 into x plus 2 by x minus 2 is given. So by x minus 2, cancel. This is as x plus 2 when x not equal to 2, 0 when x is equal to 2. When you draw the graph of this one, you can obtain like this. See, it is y is equal to f of x is nothing but y. So y is equal to x plus 2 is a straight line. Y is equal to x plus 2 is a straight line. It will be like this. Here there is a break because at x is equal to 0, here is the break, because at x is equal to 2, the value of the function is 0. So there is a break here. Exactly at x is equal to 2, we are taking 0. 0. That means this function is not continuous in this domain. At x is equal to 2, the function is not continuous. At x is equal to 2, the function is not continuous. So you can understand that this function is not continuous at x is equal to 2. Okay. Next, one more example I can give you. Like, so how to check the function is continuous or not continuous? For example, see, first you will have to find out the limit of the function at x is equal to the point c, whatever they give. You find out this limit, then if this limit value is equal to the value of the function at x is equal to c, that means you find out this limit value and you find out f of c. So if both of these are equal, then you can say that f of x is continuous at x is equal to c. This is the definition 1. So one more definition is there. Sometimes what happened, directly we cannot find out the limit. That time I may need to use the left hand limit and right hand limit concept. What is left hand limit? It is limit x tends to c minus f of x. It is nothing but limit h tends to 0 f of c minus h. Right hand limit x tends to c plus f of x, which is nothing but limit h tends to 0 f of c plus h, and these two we must be equal. Left hand limit is equal to right hand limit, also is equal to f of c. Then this is definition 2. Then also you can say the function is continuous at x is equal to c in this time also. This is the definition 1, definition 2. Briefly let me explain by taking the graph of this function. See, for example, at x is equal to c, I am explaining. This is the point c. Okay. So the value of the function at x is equal to c is f of c. So this limit value, limit x tends to c, f of x is equal to f of c. That means there is no break. Limit is same, the value is also same. Okay. Then the function is continuous. Okay. Next, what is this left hand and right hand concept? See, if I magnify it, see, zoom it. If I zoom it like this, if you zoom it, so there will be a c minus h on left side, c plus h on right side. So at c minus h, whatever the value you get, at c plus h, whatever the value you get, all of them must be same, f of c only. The value should not change. So that means it is after so many magnification you will get all will reach approximately same value. That means so that f of c minus h, f of c plus h and f of c, these three values are same. These three values are same also, I can say that the function is continuous. When I can use this definition? When I can use this definition, means definitions are 2. As I explained you, definitions are 2. Definition 1 and definition 2. When can I use these definitions? When, see, the definition 2 can be used when these functions are of modulus type functions, greatest integer functions, signum function, and tan x at pi by 2, at x is equal to pi by 2. Since such kind of cases are coming, you just find out, use this definition 2. When these polynomial functions are coming, polynomial functions, sin x, some functions are continuous everywhere, some functions will have the domain as set of real numbers. Such functions when you are seeing, you can use the definition 2 directly. Almost probably for the polynomial and algebraic functions you use the definition 2, definition 1. Algebraic functions you use the definition 1, and if it is a polynomial functions, modulus function, greatest integer function, mod x by x, tan x, x is equal to pi by 2, such cases definition 2 we use. And one more thing, you please understand that when it is like this is given, piecewise defined function. What is that? What is a piecewise defined function? Like this will be given, f of x is equal to x square plus 2 when x is less than 5, and then 4x plus 7 when x is greater than or equal to 5. This time also I have to use definition 2, LHL, RHL, f of 5 you have to find out. When these piecewise defined functions are given, the point which is mentioned here, this is the point we have to take. At that x is equal to 5, we have to find out the limit. How it is like? Now let me discuss the continuity of this function. At x is equal to 5, left hand limit is limit h tends to 0 f of 5 minus h. Because at x is equal to 5 we are checking. Okay. And then right hand limit means limit h tends to 0 f of 5 plus h, f of 5 plus h. So these two we will have to find out. So left hand limit means 5 minus h means what? 5 minus h means it should be less than 5. So we have to use the first value, x plus 5, x square plus 2. So it is limit h tends to 0, 5 minus h whole square plus 2. उसके बाद you substitute h value, h tends to 0 na, h is equal to 0, substitute, you will get 27. Similarly, right hand limit means 5 plus h. 5 plus means more than 5. More than 5 means 4x plus 7. So I have to use 4 into 5 plus h plus 7, which is 4 into 5 plus 7, such that I can substitute h is equal to 0. It is also 27. All both of them are equal. LHL is equal to RHL. One more thing is left. I will have to find out f of 5. F of 5 means I have to use the second function. Equal to symbol is here. So it is 4 into 5 plus 7. 20 plus 7, 27. So the function is continuous everywhere. So if I take one more example like this, greatest integer function is not continuous. F of x is equal to step x is not continuous at x is equal to a belongs to z. Z means integers. At integral points this function is not continuous. At integral points this function is not continuous. So why it is not continuous at integral points? The function is not continuous. I can say that because we find out left hand limit a minus h, which is limit h tends to 0, step of a minus h. You know very well what is step of a minus h means a minus 1. For example, because it is like a minus h means 2 minus h means it is less than 2. Less than 2 means it is 1.99999 like this. It is 1. So that's why it is 2 means 1 less than that. So a minus 1. Right hand limit is equal to, and if it is right hand limit, like this, it is limit h tends to 0 f of a plus h, which is limit h tends to 0 step of a plus h, which is equal to, it is a only. A plus h means like 2 plus 0 means what? 2 plus 0 means 0 point something. It is 2.00000000001 like this, very small, though it is 2. Okay, so you, from this all things you understood, from the graph everything you understood, that continuity of a function at a point means that x is equal to a. Just I am defining the continuity of the function. It should be limit x tends to a, f of x is equal to f of a. This is the definition 1. That means if it is a graph at x is equal to a, whatever the value we get, this f of a, these two must be equal. So at x is equal to the limit value and the value of the function, both of them must be equal. So now the definition 2 is, we have to find out left hand limit and right hand limit and f of a. All three you will have to find out. Left hand limit means limit h tends to 0 f of a minus h. Right hand limit means limit h tends to 0 f of a plus h. F of a plus h. So this value also you will find out. If left hand limit is equal to right hand limit is equal to f of a, then the function is continuous at x is equal to a. That means you are doing like this. See, this is the graph. See, at x is equal to a you are finding the value. At x is equal to a you are finding. At x is equal to a you are finding. It is f of a and it is f of a minus h. This is a minus h and this is a plus h. This is a plus h, and then at a plus h it is the value is f of a plus h, f of a plus h. So these three are approximately equal. They need to be equal. Then you can say the function is continuous at x is equal to a. Now how to define the function is continuous in an interval? The continuity of a function. The continuity of a function in the interval, closed interval AB. When I can say the function is continuous in the interval, closed interval AB. See, if you take this is A and this is B, both are included. When I can say the continuity, a function is continuous in this interval, see this is A and this is B, right? The right hand limit of A, left hand limit of B must be defined, and everywhere, whatever the point inside this interval you take, anywhere, C, it is C. So at C also the limit must be defined and the value of the function also equal. That means at A right hand limit at A is nothing but limit h tends to 0. Limit h tends to 0, f of a minus a plus h is equal to f of a. Right hand limit h tends to 0, f of b minus h is equal to, say left hand limit here. At x is equal to a, right hand limit, at x is equal to b left hand limit, it is left hand limit, okay, it is equal to f of b. So these two must be defined like this, and also for all c belongs to open interval ab, limit x tends to c f of x is equal to f of c. If all these three things happen, then the function is continuous in the closed interval ab, I can say that. So from graph easily you can understand, okay. So that is the continuity of a function in the interval. For example, you want to check sin x continuity. So you find out limit x tends to c sin x. It is sin c, no problem. So what is f of c? F of c is also sin c. These two are same. So the sin x is continuous everywhere. Similarly, cos x is continuous everywhere. Similarly, x square plus x plus 2 is continuous everywhere. Same process you can follow. Very easily you can decide the continuity of a function in the given domain. Set of real numbers or given interval, wherever it is. If for example in sin x continuity in some interval minus pi by 2 to pi by 2 they asked, that time what you have to take, this c value you have to take in the interval minus pi by 2 comma pi by 2, okay. So that is the way you find out the continuity of the function in an interval. So for example, if it is sin x continuity you are finding in the interval x belongs to minus pi by 2 to pi by 2, you tell me what to do. So at x is equal to minus pi by 2 right hand limit, at x is equal to plus pi by 2 left hand limit, and take any point c in this process you find out. Three process you explain, then the function is continuous everywhere in the interval wherever you take, you can say that. That is about the continuity of the function in an interval. Also I hope you understood everything about the continuity of the function. Next session we will have to meet with the problems based on this continuity of the function. There are many problems are there, I will discuss in the next video. Thank you very much. Thank you very much. Please go through the PDF what I sent you, and also please try to watch the video. If you don't understand, repeat it and watch it. Any problem you are facing in watching, otherwise anywhere you are not understanding, please make a question, put a question in the WhatsApp. I will try to explain it. So stay home, stay safe, do hard work. Wish you all the best. Thank you very much everyone.